Hey guys, welcome back to another video. In this video, we're going to look into position graphs in simple harmonic motion. So we all are quite used to graphs looking like velocity against time or acceleration against time or displacement against time. Now we have to understand the concept of either velocity against displacement or acceleration against displacement. Now, for this, we have taken an example of a bob experiment or a bob with string attached. So, in this case, we're taking rightwards as negative, meaning if you are right of the equilibrium, you are going to be negative. If you are leftwards of the equilibrium, you are positive. So this is the direction key. Now granted, that is how we're going to assign the signs. Let's first understand the acceleration against displacement curve. So on the x-axis for position graphs, you're going to label it as amplitude, negative amplitude, and the positive amplitude, the maximum displacement from equilibrium on either side of the axis. One is going to be negative, the other is going to be positive. Now understand that at the topmost position, which is the maximum displacement upwards, you have displacement max, or you can call it amplitude. Displacement is equals to amplitude or x naught, because the displacement from equilibrium is the maximum. Great. Now when the displacement is maximum, you should also know that the velocity is 0. Why is the velocity 0? The velocity is 0 because at this position, at position 1, the bob is instantaneously at rest. Meaning, when it rises above, it has max PE, potential energy, and it has 0 KE, kinetic energy. What is kinetic energy? Half mv square. If Ke is 0, that means velocity is 0. So we know at the extreme position where the amplitude is A, where it's displaced by the amplitude, the velocity is supposed to be 0. Now, if you have good concept about differentiation, you should know when velocity is 0, the acceleration is maximum. The acceleration is maximum. So, acceleration is max. Now, we have already talked about how A is equals to minus omega square x comes about. Therefore, you should already understand that if the displacement in this case is negative, meaning right of the equilibrium, we plug in A is equals to minus omega square minus times minus A, and we get omega is positive A omega square. Meaning, A is equals to omega square A. So what this means is, if the displacement is in this direction, the acceleration is in the opposite direction. There's one simple way that we can prove this. And for your ease of understanding, let's quickly get over that. Right. So if we start from this position, position 1, and draw a displacement against time curve, what is it going to look like? So taking this as time and this is x or displacement, let's start off with this position where the displacement is maximum. In which direction though? It is negative. Let's start from the negative axis. The displacement is negative. Therefore, we start from the from below the axis, and it's going to look like you know that x can be denoted as, displacement can be denoted as a sine t or a sine omega t, right? Alright, so this is known from the previous videos that displacement can be written as a sine omega t. If you've forgotten that, you can watch the video again and understand why. So if x is denoted as a omega t, we can say a sine omega t. In this case, we're using another formula, x is equals to a cos omega t, because we're starting from the maximum displacement. So this is also explained in the previous video why x has two formulas. The displacement has two formulas. Either you start from this position where the formula is sine, or you start from maximum displacement where the formula is cos. Great. So if the formula is cos and it is actually minus a cos omega t, because we're taking right as negative, it's going to look something like this. Sorry for the horrible curve, but this is the main idea of the displacement over time curve, right? If this is the case, if you differentiate it and try to get the velocity against time curve, what is it going to look like? The simple idea is that you translate this curve or move this curve 90 degrees leftwards. What do? For differentiating displacement against time, you simply move this 90 degrees and you get the new curve for velocity against time, or omega t. Velocity against omega t. So what do you know about the equation of velocity? Velocity is going to be given by, in this case, v naught, which is the maximum velocity, times sine omega t. Great. This is the formula for the velocity. Now if you want to get the acceleration, you further differentiate it and you get the acceleration curve, where you're going to again displace it by another 90 degrees and get a new curve, which is giving you a positive cos curve. So a is equals to you can say minus omega square x, or a is equals to, so a is equals to v naught maximum velocity times omega times cos omega t. Therefore, you can break v naught into a is equals to a omega times omega into cos omega t. Now from the initial equation, you can say that over here that x is equals to minus a cos omega t. Therefore, you can substitute this value with this over here. If we want to substitute a cos omega t, we can say minus x is a cos omega t. Therefore, we can say a is equals to minus x omega square. This is also how you can prove that acceleration is negative. Acceleration is indeed negative if the displacement is positive. Meaning, this is also how we can derive this equation. Great. So, we know we have just shown another proof of a is equals to minus omega square x. So now, the point of doing all that is giving you another derivation and another way to look at a is equals to minus omega square x. And the other point is, if displacement is maximum, velocity is 0, and if velocity is 0, the acceleration is maximum. And you're going to get a positive value. Why? Because notice that the displacement is negative. What does A is equals to minus omega square x tell you? It is telling you that if the displacement is negative, the acceleration will be positive. Acceleration is supposed to be the opposite. Acceleration is supposed to be in the opposite direction of displacement. Therefore, if the amplitude is negative, the value for acceleration is supposed to be positive, and it's going to be maximum for this position. So at minus a, what is the value for acceleration? Omega square a. How? A is equals to minus omega square x. You plug in the value of minus a is equals to omega square a. Minus and minus gets multiplied and turns into plus. Great. So now we understand how this is coming back, right? And similarly, for positive amplitude, you're going to get a minus omega square a as the value for acceleration. So if x is equals to a, you know acceleration is negative. If x is equals to minus a, you know acceleration is positive. Great. Now, if the question asks you what is the gradient of this curve, it's very simple. Since on the y-axis, you're taking what? A. And on the x-axis, you're taking the displacement or the amplitude. This. Therefore, what is the gradient? The gradient is minus omega square. Minus omega square. Notice that this is a linear line and has a negative slope. Right? What would be a positive slope? This. So the gradient of this curve is minus omega square. Great. If you understand that, now let's get to velocity against displacement. By the way, for acceleration against displacement, try to always plot the maximum value and the minimum value and the amplitude on either side, right? Those are usually the things that they're going to look into. So yeah, this is how almost all acceleration curves are going to look like. I mean, acceleration graphs, not curve. Anyways, now what is this velocity against displacement? This is, you can already guess it's an ellipse or it's shaped like an oval. But how is this equation derived, right? How is this long equation derived, and where is this coming from, and why are we using this? Now, for velocity against displacement, I've already shown you one formula, which is this. Now, this is, notice, is with respect to time, right? It is with respect to time. However, you might be told that you don't know the value of time or how long it has been. You're given the information that the displacement of any oscillator, let's say, is 2 centimeter. In this position, what is the velocity of the oscillator? In that case, what do you do? What formula do you use? We're going to use this formula. How is this derived? I'm going to show that in another video, in the next video, most likely. But this is the equation that is given, and you don't need to understand or know the derivation of it. Just try to understand how to manipulate this and calculate different values. So if I try and explain different variables in this equation, notice this is omega, which is a constant, and this is the angular frequency. This is plus minus. Velocity can be both positive and negative depending on the side, depending on which side your oscillator is at, right? So if let's say this is positive and this is negative, you know this oscillator is moving with a positive velocity if moving this way, and you know this oscillator is moving with a negative velocity if moving leftwards. Great. So that is why there is a plus minus. And the other thing is, under the root there is x naught. What is x naught? X naught is simply the amplitude. X naught is simply the amplitude. What is x squared? X squared is the displacement at any given position at any given time. So the they might tell you that x is equals to this, x is equals to 2 centimeter, x is equals to 5 centimeter. Find out the velocity in this position, right? So with those informations, you're going to plug in those values and get the velocity. And depending on in which position it is, if it is left or right, you will have to give a positive or negative value. If they want the magnitude, then it's always going to be positive. What is the speed, let's say? In that case, you're always going to give a positive value. In case that they want the velocity, you give a negative value, depending on the question. Right, now how are we getting this curve? Great. So for this curve, let's look at this bob. Now, what's happening at position 1? You know, at position 1, the velocity is 0, right? At position 1, the velocity is 0. Why? Because displacement is maximum. The displacement is maximum, right? If the velocity is 0 at position 1, when it moves to position 2, you know the velocity is supposed to be maximum. That's why you plot this. So right now we have 2 dots or 2 plots on the curve. Graph. So next, if we try to look at position 3, what's happening over there? The velocity is again 0. The velocity is again 0. Great. So we plot another point, which is on the x-axis A, because it's the maximum displacement. Next, in this case, the bob is coming back in this direction, moving which direction? Rightwards. Rightwards is negative. So in this position, we know the velocity is maximum. If you know the velocity is maximum, you plot minus v over here, which is the max value of velocity, the speed, maximum value of speed, but in the opposite direction, which is why there is a negative sign. Great. So now what you have is basically 4 distinct points on the axis. Great. So with this information and this equation, if you have to draw a curve, it's going to be an ellipse. It's going to be an ellipse. So from this, you should already know and remember that when you're supposed to plot and sketch a curve for velocity against time, it's always going to be an ellipse. Why? Because it is coming back, it's continuously coming back to the same speed, same velocity. And if you take a graphing calculator and plug in this equation, you're going to get an ellipse. Granted that you have put in value for all the constants. So just put in random values for omega and x naught, meaning the amplitude, and you're going to see it's an ellipse. Great. So from this, we know that if velocity against time is plotted, we're going to get an ellipse. Now, how do we use this equation? Understand that you may be asked to calculate maximum velocity and the cases where the velocity is 0. Great. So in that case, let's understand this equation. V is equals to plus minus omega x naught square or amplitude square minus x square. Great. So let's say you have to find out the maximum velocity. When is the velocity going to be maximum? When the value inside this root is maximum. The value inside this root has to be maximum so that the total velocity is greater. When is this value going to be maximum? That is going to be when x or the displacement is 0. Therefore, velocity is going to be maximum when the pendulum is in this position where the displacement is 0. We already know that velocity is maximum at the equilibrium position. So if you know that, let's apply that. And we get v is equals to plus minus omega a square minus 0. What do we get? V is equals to plus minus omega a. Square cancels the power and you get v is equals to plus minus a. Now if you remember the previous equations, what was the maximum value for velocity? A omega. What have we received over here? A omega as well. So that is the beauty of both of these equations, that they do not give contradicting values. They are going to always give you the accurate and the same value for velocity, granted the time and displacement matches. Right. So you know the maximum velocity is a omega. Nice. Now, when is velocity 0? When is velocity 0? For that to be the case, you know, this entire part has to be 0. Right? If this entire part has to be 0, the value inside has to be 0. Now, when is that going to be the case? You know, velocity is 0 at the maximum positions, at the extreme positions where the displacement is maximum. So if the displacement is maximum, if the displacement is indeed maximum, you can say x is equals to a, amplitude. Nice. So you can say v is equals to plus minus a square minus a square, and v is equals to plus minus 0, or v is 0 meter per second. This is when velocity is 0. Great. So this is how you can use the equation to get different values. You can get the answer for velocity or displacement if the velocity is given. So you need to understand how to use this equation. Great. So that is it for this video. If you have any question, let me know in the comment section and I'll try and answer it.